Happy Monday, everybody. Welcome back to another Planetarium live stream. My name is Patrick Hess. I'm the Planetarium Specialist at Union Station. And this here is Phoebe, my assistant. And welcome back. We are streaming live here in Kansas City. And Phoebe's very excited about it. I hope you are too. So welcome back. We are going to be taking a deep dive into satellites today. And if you're a first-time watcher, then thanks for joining us. If you don't know, we are the Planetarium at Union Station, Kansas City, and we are open to the public right now. Here you go, Phoebe. So if you want to come see one of our live shows, you can, or any of our other pre-recorded documentaries. They're great as well. But, of course, watching us online is a great way to support us, too. And if you're a returning watcher, welcome back. Thanks for joining us. As a reminder, this is a live stream. So if you have any comments or questions or shout-outs you want to make, or just you want to let us know where you're watching from, it's always fun to hear where people are watching from, then post in the comments, because we will read those comments. Already having someone chiming in, Octavia, who is saying hello from Mexico, it looks like. That's amazing. Well, thank you so much for watching. Phoebe's very distracted by these walnuts. Here, come here. So welcome back, everyone. I'm getting distracted, too. If you don't know, we have been streaming from, well, my living room for the past bunch of months, almost 10 months now. We have done over 50 live streams, and if you missed any of them, don't worry, because we have a YouTube channel. Just search for Arvin Gottlieb Planetarium on YouTube, and you can find us there, and all of our past streams are posted there. We've covered so many awesome topics, which I will give shout-outs to throughout the stream today, as they relate to some of the things we've covered today. So don't worry if you've missed any of our streams and you're a first-time watcher, you can go back and rewatch all of our streams. A couple quick shout-outs. We are currently at, we're currently at a whopping 62 subscribers on our YouTube channel, which is pretty exciting to me. But if we get 38 more, if we get to 100 subscribers, then I can finally make it youtube.com/KC Planetarium, other than just sort of the random letters and numbers. So that'd be a very exciting milestone. So if you haven't yet, if you have a YouTube account or even a Google account, go over to YouTube and search for Arvin Gottlieb Planetarium, and please subscribe to us on there. That'll help us a lot. And don't forget, if you are watching on our Union Station Facebook page, head over to the Arvin Gottlieb Planetarium's Facebook page, where you can subscribe to us there, and we post all sorts of exciting news updates related to space exploration and astronomy. Speaking of which, I like to start my streams by giving some astronomy and space updates. So let's do that after I go over a couple more shout-outs. Looks like Sarah's watching. Very excited to see Phoebe. Phoebe's currently snacking on some walnuts on my desk. We'll get her back into the shot here in a second. Chris, one of our longtime watchers, is checking us out as well, watching from downtown KC. Thanks so much for watching, Chris. Thanks for joining us again. And Debbie is watching from Richmond, Missouri. Thanks for watching, Debbie. Again, if you have any questions or comments, feel free to throw those into the comment section, and we will answer those in person. So we're not going to spend too much time going over space news, but there was one cool news story that I did want to bring up. So let's bring it up over here. This is a pending paper. I know this is super exciting, but this is a paper that is to be published about the discovery of 6 planets, 6 exoplanets, orbiting a star that's pretty close to us, 200 light years away. And it's a very unique planetary system. And so let me actually show you this planetary system. All right, let's full screen there. So this planetary system is unique because it has orbital resonance. So first of all, this was discovered by the University, or at the University of Geneva, using the European Space Agency's CHEOPS satellite, which stands for Characterizing Exoplanets Satellite, as well as the ground-based ESPRESSO, which stands for a Shell Spectrograph for Rocky Exoplanets and Stable Spectroscopic Observations. I swear, space scientists and astronomers really love their acronyms, and sometimes they really stretch it. But anyway, they used this observatory to detect these exoplanets, and it found a 6-planet system with 5 of the planets in orbital resonance. So the innermost planet, as you can see in blue there, is not resonant, but all the other ones, which are being highlighted in red every once in a while, are in orbital resonance. So what this means is that they orbit in a nice pattern. Ooh, I want to replay that. So you can actually mathematically determine a ratio of orbits. So the orbital resonance specifically for this system is 18, 9, 6, 4, and 3. Essentially what that means is the second most inner planet orbits once or twice for every one time the next one out orbits. And then the third one orbits every 6 times the third one orbits, the second one orbits 9 times, and then the innermost one orbits 18 times. So anyway, it's a nice ratio where you can actually divide up their orbits. Now, we've actually talked about orbital resonance quite a few times in our streams. There is an orbital resonance between Neptune and the Pluto system, which we call the Plutinos, which I have already claimed as my band name, by the way. You can check out those live streams on December 4th and January 4th. Of this year. We also talked about orbital resonance with minor planets and asteroids. There are a number of asteroid systems that are resonant with planetary orbits. That stream was on November 9th. Mercury is in a spin orbit resonance, and Venus is in an orbital resonance as well. And that stream was on October 12th. And then we've talked about many of the moons in our solar system. Jupiter's moons, Io, Europa, and Ganymede are in an orbital resonance as well. And you can check out streams about Jupiter on... You can check out that one on June 29th. And we did a stream all about moons on September 14th. Phoebe is in rare form today. Come here. Come here. He's very excited. We just want some scratches? How about just some scratches while I talk about planets? Now, this system is very cool and very close to us, but none of these 6 planets are in the star's habitable zone, so not the right distance for liquid water to exist. There could still be life in a form that we don't quite understand, but it's still pretty interesting. So pretty cool planetary system. There are only 5 other star systems that have been discovered to have resonant chains involving 4 or more planets. So a pretty exciting discovery there that was just announced. Another cool announcement. Bird, you're getting stuck on your own tail. Another cool announcement is that there was a historic launch by SpaceX the other day. We posted it on our Facebook page. And this was the Transporter-1 launch. And this launch broke the record for most satellites launched on a single mission. So this launch was the first of many planned for the SmallSat rideshare program, which I love. It's kind of like Uber for satellites. But basically, this is a mission by SpaceX to launch a number of small satellites all together to kind of kill a lot of birds with one stone, basically. So this launch launched 133 commercial and government satellites and 10 Starlink satellites aboard just one rocket, which is pretty crazy. And the Starlink satellites in this mission were also the first to deploy in a polar orbit, which is pretty exciting. Bird, you're not going to chew on my chair, are you? You probably will. There. Oh, are you going to be part of the stream or no? Oh, she's going to chew on my chair. Okay. Well, everybody say bye to Phoebe. She is a little rare form today, so we're going to let her chill out in her cage, and we're going to continue our stream in just a moment. All right. Okay. Continuing onwards. One other news piece. Today was supposed to be the... here's the bird. Today was supposed to be the Starship 9 test. All right. Phoebe, are you going to keep doing that? She's very upset that she's not a part of this stream. Let's see if she calms down a little bit. Nope. All right. Okay. I think we're okay. So today was supposed to be the Starship 9 test. So Starship is SpaceX's new platform. That's an extremely large rocket, and they've done a bunch of tests. And there was supposed to be one test today, but it was scrubbed due to 30-mile-per-hour winds. So that test is going to be moved to tomorrow, and it should be pretty cool. It's not going to go into orbit, but it will be a very high-altitude test, and they're going to try to land this massive rocket, this 10-meter-wide rocket, softly down on the Earth. The test number 8 was not quite as successful. It had a rapid unplanned disassembly as it crashed into the Earth. But hopefully tomorrow's launch will be a little bit more successful, and we'll definitely post on our Facebook page about that. So be sure to like and subscribe to the Arvin Gottlieb's Planetariums page to get all those updates. And one last quick update about our live streams. I wanted to give a huge thank you and shout out to all of our watchers, both new and old. I wanted to thank you all for supporting us over the past 10 months because we just hit a huge milestone. We now have accrued over 250,000 views, which is incredible and so amazing. And I just wanted to personally thank everybody who's watched and supported us because that's just a huge milestone. And this is not something that I really ever expected to do for my job, but it's something I've really enjoyed. And it's something that hopefully you all have enjoyed. Clearly, there have been a lot of you who have watched, which I really appreciate. But we were going to keep these going for the next few weeks and months, and we will of course keep you updated as our schedules get updated and changed. But this has been a great way to support the planetarium, keeping us relevant and in the public's eye. So thank you to everybody who's watched and everybody who has shared our live streams. I've had a ton of fun doing them, and I'm gonna have fun into the future as well. Let's check back into the comment section. Tasha's watching again. Thanks for watching again, Tasha. The kids and I are watching during bath time. My 2-year-old loves the tweet of Phoebe. Well, Phoebe loves tweeting as well. Tracy says, hi, Lawrence, Kansas girl in North Carolina. Well, thanks for watching, Tracy. And hope North Carolina's treating you well. Kansas misses you, I'm sure. I'm a Kansas boy myself. Andrea says, hello from Portland. Thanks for watching, Andrea. That's awesome. Linda saying hello. Hello, Linda. Dennis, Casey, Kansas. Kansas City, Kansas is here. Awesome. Thanks for tuning in. Eric and Granny are watching from Lenexa. Thanks for watching, guys. Dustin says hello from Philadelphia. Happy for your Kansas City Chiefs. And Andy Reid, we are very happy for them too. Very, very excited about that. Nothing else to say, just that you know, we will see everybody in Tampa pretty soon. David says hello from Minneapolis. Go Chiefs. Awesome. Yes, go Chiefs indeed. Patience, one of our longtime watchers as well, saying good evening. Great job. Pat on the back for you. That's one amazing milestone. Thank you so much, Patience. Couldn't have done it without you and without everybody else who watches every week. Beth says hello from Omaha. Thanks for watching, Beth. And Linda, we enjoy this very much, and we enjoy you watching, Linda. So thanks so much for watching. All right, so we're going to dive into our deep dive today. We are going to talk about satellites. Now, I wanted to do a couple little notes at the beginning. So we are going to cover a lot of satellites and the different categories of satellites, but we are going to kind of gloss over space telescopes because space telescopes actually got their very own live stream. We covered space telescopes on October 5th of last year, so check out that stream if you want to learn about Hubble, the James Webb Space Telescope, Kepler, and a bunch of other awesome space-observing telescopes. But today we're going to focus more on the Earth-observing satellites. And I also want to kind of define what a satellite is. So a satellite is any body that's orbiting another body in space. And there are a lot of natural satellites. We call them moons generally. And we've talked about moons and other natural satellites on our September 17th live stream. So those are natural satellites that have just come from nature, either during the formation of the solar system and planetary formation, or via capture. So asteroids that were captured by the gravity of large objects like Jupiter and Saturn and other big planets like that. Even some smaller planets have captured moons as well. Now, technically, spacecraft and space stations are satellites, and we're going to be talking about man-made satellites or human-created satellites today, and that includes all of the uncrewed automated satellites as well as the spacecraft and space stations that I just mentioned. So we're going to cover all those in our stream today. And we're going to kind of go back in time just a little bit and talk about the history of satellites. But really, we're going to go even further back and talk about the history of the idea of satellites. And this actually dates all the way back to Sir Isaac Newton. So Sir Isaac Newton in 1687 wrote this paper or book, you could call it, called A Treatise on the System of the World. And in it, he had a thought experiment that today we call Newton's cannonball. And his idea, again, this was in 1687, his idea, he visualized a huge cannon at the very top of a very high mountain. And he imagined launching something out of this cannon. Now, if there were no forces of gravitation or air resistance, the cannonball should follow a straight path straight away from the Earth, right? In the direction that it was fired. But we know that there are gravitational forces that act on that cannonball, so it'll follow a certain path. And this path will be based on its initial velocity. And Newton did a lot of calculations, and he had a lot of ideas about gravity, as we all know. And so he was one of the first persons to propose this idea of, launching an object sort of parallel with the Earth. And he thought that the faster you launched it, the farther it would go. And he visualized a scenario where you could launch it fast enough that it would actually, it would continue to fall forever, and it would sort of escape the gravitational pull of the Earth. As you can see in this diagram here, that's kind of the idea. And this was, again, all the way back in 1687. Now, the first fictional depiction of this in a book was actually by Edward Everett Hale in a book called The Brick Moon that imagined a man-made satellite like this. And then more famously, Jules Verne included this idea in his 1879 book, The Begum's Fortune. You can see the idea of sending something into orbit popping up in fiction really for over a century, and again, dating back many centuries, scientific thoughts about orbiting the Earth. In 1945, Arthur C. Clarke, another famous author, he wrote about the possible use of communication satellites. So by that point, we were already starting to think about how we could use these satellites. And then in 1946, just a year later, the United States Air Force actually started some serious investigations about satellites. Fast forwarding again to 1955, the White House announced on July 29th, 1955, that they intended to launch satellites by the spring of 1958. And they called this Project Vanguard. 2 days later, on July 31st, the Soviet Union announced that they intended to launch a satellite by fall of 1957, attempting to beat the United States. Now, this exchange is considered by many to be the true beginning of the space race, although it was really Sputnik that was kind of famously started this race between the United States and Soviet Union to get to space. So let's talk about that space race. The first satellite ever was Sputnik, so you could say that the Soviet Union maybe won this part of the space race, or at least they fired the first shot in the space race, you could say. And this tiny satellite was about 23 inches in diameter with 4 external radio antennae, which you can see here. It was launched on October 4th, 1957, and it orbited for 3 weeks until its battery died, and then it kept orbiting for about 2 more months. We could detect it until it actually fell back into the Earth through the atmosphere. This satellite broadcasted radio pulses that were easily detectable, so radio amateurs around the world could detect it. And its inclination, so the angle that it orbited, was high enough that it basically had a flight path over the entire world. So basically everybody could see this satellite, everybody could detect it. So again, a lot of people consider this sort of the first warning shot to the world, saying the Soviet Union could get to space. Now, by the way, we're going to talk a little bit about orbits today. We dive a lot more in depth about orbits during my Spaceflight 101 live stream, where we actually built a rocket and launched it into space using Kerbal Space Program, a really fun program. And that was on December 14th. So if you want to learn more about sort of orbital mechanics and what it takes to get to space, then check out that one. We'll talk about that a little bit during our stream where it's relevant today, though. That is a fun stream, though. It was my longest stream ever. Pretty cool. Now, the United States followed the Sputnik probe in January 31st, 1958, and this was with the launch of the Explorer 1, which the reason we're doing the stream today is because January 31st is coming up, so the 63rd anniversary of this launch is coming up. So we're just kind of celebrating Explorer 1 during our stream today. Well, it happened to line up very nicely with my content plan. Now, this probe was fairly small, similar size to Sputnik, but just a lot thinner and longer, as you can see here. And it lasted a bit longer than Sputnik. It actually returned data until its batteries ran out after 4 months, and it even stayed in orbit for 2 more years until 12 more years until 1970. And it did collect some interesting science. It was actually the first spacecraft to detect the Van Allen radiation belt. And it was the first part of the NASA's Explorer program, which actually has been ongoing to this day. There have been 90 scientific missions in this program that started with Explorer 1, including the WISE satellite, which was the satellite that detected Comet NEO-WISE last summer. If you want to learn more about comets, check out our July 13th live stream where I create a comet using ingredients I buy at the grocery store here in my living room. It's a fun one. Again, July 13th. Check out that one, all about comets. Now, there were a few additional satellite launches that took place between the Soviet Union and United States after Sputnik and Explorer, but crewed missions soon took precedent as each of these nations attempted to one-up each other, outdo each other by achieving human spaceflight first, which the Soviet Union achieved, and then landing on the moon first, which the United States achieved as well. So this is a cool little chart showing us sort of the track of manned or crewed spaceflight here. And then up here we have the satellites. You can see there weren't quite as many satellites once we started sending people to space, but we did continue sending satellites after that, of course. By the way, just a quick shout out to another live stream. On November 30th, I did a live stream all about Earth's moon. That's a fun one. And then if you're wondering if we really did land on the moon, the answer is yes. But if you're wondering why we know we did land on the moon, and you want to learn about if the moon landing was faked or not, well, it wasn't faked. If you want to know why we're sure it wasn't faked, then check out my July 20th live stream from last year. That was actually a Hollywood live stream where I talked about space in the movies, but we start by talking about if we faked the moon landing. By the way, last week I did another Hollywood live stream covering a bunch of cool movies like The Martian, so don't forget to check out last week's live stream if you missed that one. Don't forget, everyone, this is a live stream, go figure. And if you have any questions or comments, want to give a shout out, want to say hi, be sure to throw those in the comment section and we will keep an eye on those. I love hearing everybody's comments. It makes it nice and interesting. And if you have a really great question, throw it at me. There's no such thing as a stupid question. You just might get a stupid answer. So, satellites today. So we're just going to fast forward and we're going to talk about what what the current landscape of satellites look like today. So today, there are almost 6,000 satellites that remain in orbit. There have been about 9,000 total launched since 1957, since Sputnik, but a third of them have fallen back down to Earth. But those aren't the only artificial objects in space. You could argue that the 13,000 additional pieces of space junk that we track are also man-made satellites. So there are nearly 20,000 artificial satellites, artificial objects that are orbiting the Earth in space. And how do these break down? Well, you can see here, if we break it down by a country, you can see that there are quite a few satellites. The majority were launched by the United States, 43%, and then others encapsulate the European Space Agency, the Japanese Space Agency, India, and other countries. And you can see China and Russia as well have pretty large space programs. So China has the second most of an individual country, and then Russia with the third most. Now, what's the purpose of these? Well, you can see the other breakdown there on the bottom, that the majority of them are communication satellites, and we'll talk about those today. Next to that, though, are Earth science and observation satellites. So satellites that are pointing back on Earth, observing the Earth, taking photos of the Earth, or gathering other data on the Earth's surface. We have technology development and demonstration. A lot of these are just test missions, or missions to prove launch capabilities, such as rocket technology or testing technology for satellites. Then a small number are for navigation, and then even smaller number are space science observation satellites, like the Hubble Space Telescope, for example. So a lot of these satellites that we send to near Earth orbit, or just to Earth orbit, I should say, geocentric orbit, orbits that go around the Earth. Those are mostly about the Earth. So, and another thing that's a great point. A lot of people wonder why we spend money on space travel and developing technologies to send satellites to space. Some people think it's a waste of money, but that chart just goes to show you that the vast majority of satellites that we do send to space, a lot of the money put into space travel is all going back down to Earth, whether it's communication, whether it's Earth science, weather satellites, things like that. By the way, my Thanksgiving live stream last year talked all about the reasons we should be thankful for space exploration and why it's important to spend our resources on traveling to space. That was on November 23rd, so check out that live stream if you want to learn more about why we actually go to space. But as you can see, a lot of it is to benefit the Earth. Now, there are different types of orbits. Let's go ahead. Ooh, where's the one I want to show you? First of all, I want to show you this really cool demonstration here, interactive demonstration on all of the satellites here. So you can divide the satellites up in this interactive, and there are quite a few satellites, as you can see. Now remember, these dots are much bigger than the satellite's actual size, so I wouldn't worry too much. A lot of these satellites, or the vast majority of these satellites, are so far away from one another that there's very little chance they'll, collide or anything, although that isn't always the case, which we'll talk about later. So I can divide these up, and I can actually show you all the non-junk spacecraft. So these are the spacecraft, the satellites that are currently operational, but then we can also look at space junk. So this is all junk. This is all broken satellites or parts of launches, like rocket boosters that are still floating around in space. So it's you can see there's a lot of space debris. We can also divide it up by a country here, so we can see all the United States satellites. You can see all the Russian satellites, Japanese satellites, Chinese satellites. So a pretty cool link. We can post this link in the comments section for sure. Let me make sure that we have access to that link. Now, we're going to divide these satellites into different types of orbits. Now, we can see, looking at all the satellites, that they appear to, they're not all random. There are some patterns. You know, there's a group of satellites that orbit pretty close, and there are some satellites that orbit all seemingly in the same exact distance here, a big ring around there. Some of them go really high. Some of them even track in little trains following each other along. I don't think I can speed up time on this chart, but I do believe it's in real time. But at any rate, you can see they are divided up into different sections. So we are going to divide up our discussion of satellites by their orbital characteristics. So specifically their orbital altitude, how high they go. Before we start though, let's jump into the comments. Patience says, the liftoff was nice for the shuttle, but it isn't carrying people. Excited to see what is ahead for manned rockets. Just talking about, the space shuttle program, the last shuttle launch was in 2011, and we actually haven't been sending, the United States at least hasn't been sending people to space ourselves until last summer, actually. The SpaceX Crew Dragon capsule did carry United States astronauts to space, so that's really exciting. So there is development there. It just is kind of moving away from NASA, although NASA's working on their own crewed missions, specifically, though, to go further than low Earth orbit, to go back to the moon and maybe even to Mars. Eric asked, did the satellite race push solar panel technology? It seems like batteries don't lead to a long-lived satellite function. They definitely did, Eric. That's a great question and a great point. And we're not going to talk too much about the technology of satellites today, but we have talked about space technology. I talk about how satellites and other spacecraft are powered during my Spaceflight 101 live stream on December 14th. So if you want to dive more into that, check out that one. Yes, definitely. So those initial satellites, as part of the space race, we just wanted to get into space as quickly as possible. But solar panel technology wasn't really used for space travel until quite a bit later, until really after the space race, to be honest. Stephanie says, so engaging. Well, thank you, Stephanie. I appreciate that. Glad you're watching. Dee Dee says, can there be too many satellites in orbit? Is there any danger that one could fall onto an urban population? Great question, Dee Dee, and we're going to talk about that during the stream today, so thanks for asking that. The shorter answer is no. We do track all of these objects, and I'll talk about how we do a little bit later. We know exactly... We're very aware of all these satellites, and none of them will fall back down to Earth unless something happens that we don't predict, which again, we predict quite a bit about satellites, so I wouldn't worry too much about that. And most of these satellites are so small, Dee, that they would disintegrate before they actually reach the ground. In fact, that's one way that we get rid of satellites, is by purposefully deorbiting them. So we slow them down so that they fall back onto the Earth, but because they're often so small, they just disintegrate before any debris actually reaches the Earth. So a great question, Dee. No dangers there. Eric says you should do a satellite live stream on how satellites have influenced agriculture and how they help feed the world. That's a great point, Eric. And actually, I do have plans for a future live stream to dive into some science about another planet that I may have not covered yet during our live streams. We've covered all the planets in our solar system, most of the minor planets, and moons and all sorts of other things. But there's one planet that I think I have forgotten about. So thanks for bringing that up, Eric. I think we might cover that sometime in the near future. Patience says, once there was a question about space junk, is NASA worried it will get too much? Again, we'll talk about space junk a little bit later. And Lauren says, how fast and high would Patrick Mahomes have to throw a football to launch it into orbit as a satellite? That's a great question, Lauren. That's one that I don't know the calculation off the top of my head, but I bet we could find out. Let's see. I bet someone has calculated that. So now the trouble with launching a football from the Earth's surface is that there's a lot of air resistance, of course. So that would probably slow the football down. But if you manage to launch that football to a point where there was no air resistance, then you may be able to get it into orbit. Now the International Space Station travels at about 17,000 miles per hour. So, it would have to be at least that fast, if not much faster, for it to escape the Earth's atmosphere, which slows it down, all that drag. But that's a great question, Larian. I think we'll probably find out on Super Bowl Sunday, since that arm is quite amazing. Always exciting to watch the second coolest Patrick in Kansas City do his thing. And thank you all for tuning in for this live stream. All right, so let's talk about different kinds of satellites. So as I said, there are about 6,000 satellites that remain in orbit today. And how do we categorize them? Well, they are split up by different types of orbital altitudes. So let me show you this chart. Hopefully I can zoom in. Great. All right. So make sure you can see this. So this is a great graphic showing us sort of the separation of different types of orbits. And they're really divided into three main zones. There's low Earth orbit, LEO. There's medium Earth orbit. And then there's high Earth orbit. So we're going to divide these up. Now, as part, or there's also sort of a fourth category that's right between medium and high Earth orbit, and that's called Geosynchronous Orbit, which is sort of its own category. So maybe we can say 4 categories. And these may seem kind of soft, but there are some hard lines between these categories, and we'll talk about what those are. But we're going to start actually outside going in. So let's talk a little bit about high Earth orbit. And I'm actually going to bring in another interactive graphic, which is very, very cool. And that will let you explore all about the satellites. Let's bring this in here. All right, so here's a great website that has an interactive showing every active satellite orbiting the Earth. So we're going to go all the way down here, and we're going to start at high Earth orbit. Now, high Earth orbit only accounts for 2% of our unnatural satellites, or artificial satellites, I should say, man-made satellites. So these are very uncommon. And we also use this orbit as what we call a graveyard orbit. Basically, if we park a satellite above, about 200 miles above geosynchronous orbit, which again we'll talk about, then that satellite is out of the way, and if anything happens to it, it won't affect any of the operational satellites below it. So scientists park their satellites out there, so they just stay out there before they run out of fuel once the mission is over, and that's just the graveyard of satellites. There are some operational satellites, but it is fairly uncommon. There's the X-ray Observatory that is one of the high Earth orbit satellites up there, and we want that satellite to be in that orbit because it's very far, or it's farther away from all the radiation on around the Earth. So it's able to observe these X-rays much more easily. And there are a couple other observatories here that are far out there. Radio Astronomy Observatory. And when I say observatory, I mean a satellite observatory. We just call it... an observatory is just any place or instrument that is observing space. And so satellites can be observatories too. But below that is a very populated orbital path, and that is geostationary orbit. So geostationary orbit accounts for 29% of all operational satellites, and this is at just about exactly 22,236 miles above the Earth's surface. And there's a specific reason for that exact number, because a geosynchronous orbiting satellite will orbit the Earth at the exact same rate that the Earth rotates. And what that means is that it will always stay on the exact same longitude. So as the Earth goes around, it will always stay in roughly the same spot. So let me show you what I mean by that. Let's hide this here. So again, we have a satellite orbiting at this exact altitude, and then it is going to stay above the Earth at the exact same point, or just about the same point, the same longitude, the same vertical point, or vertical line, I should say. So these are fairly common, and they're very useful. So a geosynchronous satellite orbits at the same speed the Earth rotates, like I said. And they can orbit at a bunch of different angles. And so if they're orbiting at an angle, then they will cover a small portion of the Earth. So as they orbit around at the same speed the Earth is rotating, because they're at an angle, they'll kind of go up and down. And if they do that, they'll kind of go up and down one longitude path, so one axis of the Earth there. Now, if they have an eccentric orbit, so if their orbit is sort of oval shaped, then they'll do sort of a figure-8 pattern. So these are pretty useful for unidirectional communications. So basically, any communication that the signal only needs to go one way. So the most common example of this is for broadcast television and radio signals, because you only need to turn a dial and receive a signal, but it doesn't matter if it's a couple milliseconds behind, as it will be since geosynchronous orbit is very high altitude, so there is actually delay with the light signals traveling to and from the satellites. Now, there's a special type of geosynchronous orbit that we call geostationary orbit, and that is when the orbit is parallel with the equator. And the cool thing about this is that for a geostationary satellite, it will orbit above the exact same point on the Earth, so it won't drift at all. It will always be facing the exact same point. And these are really useful in meteorology and weather monitoring, as well as oceanography and volcanography, studying volcanoes and debris from volcanoes, the ejecta and dust and ash and things like that. So these are fairly common. A lot of satellites in that zone that are observing the Earth, and because they have a view of the Earth from just a single point, they can get a nice big view of the Earth that doesn't change, and they can compare the Earth over periods of time by just looking at one point on the Earth. So those are the high Earth orbit and then geosynchronous orbit satellites there. And then going down, we have the medium Earth orbit satellites, which as we saw in this chart, encompass quite a wide range of the sort of possible orbiting zones, but this is actually a fairly uncommon spot for satellites. Only 6% of satellites orbit in this medium Earth orbit zone, and this is anywhere from 1,200 miles up to 22,000 miles, up to geosynchronous orbit, basically. Now, the most common altitude is at about 12,000 miles, so let's go back over here. So we're going to pass the geostationary, and then you can see here a few satellites orbiting. So this is in kilometers. So this is satellites orbiting in that zone at about 12,000 miles. And the cool thing about this is that for a satellite at that position, you have an orbital period of 12 hours, which means that you go around the Earth 2 times every day, basically. So a geostationary orbit or a geosynchronous satellite will go around the Earth once every day, but if you orbit half the distance, you go twice as fast, basically, essentially. The math is a little different, but hopefully you get the idea. So the most common satellites in this zone are the GPS satellites. So the global positioning system is was started in 1973, and this involves a constellation of 24 satellites that were made operational in 1993. Now, originally this was only for military use, but on May 1st, the year 2000, the current president, or the president of the time, Bill Clinton, he signed into law making civilian use possible after the government actually lowered its accuracy, which is something not a lot of people know. But now we all take for granted how great GPS is because we all have it in our phones. Our smartphones are able to give us navigation with this GPS system that's been operational now for just about 30 years. The accuracy has been enhanced, so today it can pinpoint locations up to about 1 foot accuracy. But the weird thing about this, though, is that it is government run, so the U.S. government can actually deny access selectively to this system, which they have used over the years for foreign diplomacy, we will say. But all that's resulted in is all the other countries making their own GPS systems. So we use GPS, and it is an international system, but a lot of other countries have their own systems. So a lot of these satellites are, so this is the Russian global positioning system. There's Navstar, which is the United States global positioning system. You can see all those GPS satellites. And we have China's global positioning system there as well. So that is the medium Earth orbit. That's what's most common there in that medium zone. But then if we go downwards for the closest spot, the most populated zone is low Earth orbit. And you can see quite a few satellites in this zone, some all together, which we will talk about, the ones in these sort of categories here. Now, some of these satellites will go up and down, which is kind of cool. That's because they have an eccentric orbit, so they have an oval-shaped orbit where sometimes they're closer to the Earth and sometimes they're farther away. But generally, they'll stay in this zone, this low Earth orbit zone. And I will mention that this is the final category of satellites we'll talk about. So if you're still watching and you have any last-minute questions or comments or shout-outs, be sure to put them in now because we will be wrapping up our stream relatively soon. So be sure to give us a shout-out or say hello if you have anything to say, or if you have a question, let us know. But like I said, low Earth orbit, this is the most populated zone for satellites, and this encompasses 63% of all satellites. And let's actually get another view of low Earth orbit here. So we can see the different satellites, or different types of satellite systems orbiting in low Earth orbit. Well, this has medium Earth orbit as well as low Earth orbit. So all the ones inside here. Actually, this other chart was better. We're going to stick with this one. So this is anywhere from 100 miles to 1,200 miles. 100 miles is 100-mile altitude is the lowest you could possibly be without your orbit disintegrating from air resistance. So if you're orbiting the Earth lower than 100 miles, there's so much oxygen that it'll actually slow you down because of the drag. So you have to get above 100 to really get into a stable orbit. Even then, though, the atmosphere is kind of thin, and you can still actually degrade your orbit. So a lot of satellites in this range will actually need to continually thrust to kind of keep themselves in orbit. So anyway, again, this is anywhere from 100 to 1,200 miles, or approximately about 1/3 of Earth's radius. And the satellites in this zone typically orbit 11 to 12 times per day, and that's, again, their orbital period. There are a lot of very famous examples of satellites like this. There is the International Space Station, of course, the largest satellite to date. We talked about the International Space Station during my October 19th live stream from last year. That was a fun one because I built an International Space Station model out of Legos, and we talked about the history of the ISS as well as other space stations. There's the Hubble Space Telescope, also in low Earth orbit, and that is, we talked about that during our Space Telescope live stream on October 5th. Every crewed space station to date, as I said before, is in low Earth orbit, or was in low Earth orbit. There are a lot of Earth observing and monitoring satellites, like spy satellites, for example. There are Earth imaging satellites, such as the Landsat program, which is used by Google to make Google Maps, as well as other mapping things like Bing, everybody's favorite mapping system, I'm sure. This is also very common for a lot of networks. For example, the Iridium sat phone network from the late 90s. We can see Iridium here as this line of blue dots right there. And then also SpaceX's Starlink, which I want to bring up here. So Starlink is pretty exciting. We just mentioned earlier that SpaceX did a Starlink launch. And this is an ongoing mission by SpaceX to bring internet to the entire world. It's supposed to be a global broadband internet system that they've actually just started to activate from a testing standpoint. And they will charge for this service, but funds for this service will go to their future planned Mars missions, which is pretty cool. This is what commercial space exploration is all about, after all. But there are a lot of pros and cons to this specific mission. One pro is that hopefully this will bring internet to underserved populations around the world, places that there aren't reliable wired network connections. So if you had a satellite connection, you'd be able to get internet this way, so we could bring internet to even more people, which I think most people can agree is a good thing. Negatives, though, there are a lot of them. So the original target deployment is 1,440 satellites, which is a lot of satellites. You can see the constellation here of satellites, how they all connect to each other. These launches started in May of 2019, and there are 951 in orbit already. And right now, it won't stop at 1,400 because SpaceX has plans for even more. In fact, they have been approved by the FCC to launch more than 42,000 satellites, which is crazy. And again, crazy that they don't run into each other. But again, things are very big at this scale, and satellites are very small, relatively speaking. Right now, they launch 60 at a time via the Falcon 9, but they're planning on launching 400 at a time aboard the Starship rocket that they are currently testing. Now, negatives, though, there are a lot of astronomer communities and space scientists who are concerned with these Starlink satellite launches because they add a lot of light pollution. Originally, they were very bright. They had a high albedo, so they reflected a lot of light, which actually interfered with space telescopes from the ground. And now, since then, SpaceX has changed the design of the satellites, making their paint a lot less reflective, and they have a brand new satellite design they actually just started launching that's even less reflective, and that has improved things. But this is a concern to the astronomy community, all these satellites and getting into space and actually potentially blocking our view of the stars. There are also polar observing satellites useful for rapid Earth imaging. These are common for weather satellites. They orbit vertically around the Earth, so as the Earth rotates, they are able to take pictures of the Earth in these sort of sweeping swaths there. Swath, actually, there says it right there on the page. So a low Earth orbit is very common, as I said, 63% of all satellites in that range. And there are a number of advantages to satellites in this range. Let's bring this back. So satellites in this range require the least amount of energy to get to space, and that is helpful because that means rocket launches are cheaper. They provide very high bandwidth and low communication latency, so we can communicate back and forth between satellites very rapidly. and they're more accessible for servicing if we ever need to fix a satellite, for example, sending a space shuttle or another mission to it. In fact, we fixed the Hubble Space Telescope on numerous occasions with the space shuttle. There are some disadvantages, though. Satellites in low Earth orbit have a very small field of view, so they're only able to observe a small fraction of the Earth at a time. To actually get a network that is able to cover the whole world, you have to send a lot of them. So this is a map showing the Iridium sat phone network, and you can see there are a lot of satellites that are needed to cover the entire world because they're so close to the Earth that they are only able to view a small amount of the Earth. So this requires a lot of satellites to cover the whole world. Also, as I mentioned before, satellites in this region suffer from faster orbital decay because the oxygen, even in the very thin Earth's atmosphere at that altitude, is still able to slow them down. And the International Space Station, for example, is slowed down, and there are small thrusters aboard it that actually keep it from falling to the Earth. They do have to do very small thrusts every once in a while to keep the International Space Station from falling down. And then another negative is that there are potential collisions. Now, as I mentioned, they do not happen very often, but there is an example, a famous example in 2009, and this was actually one of the Iridium satellites, Iridium number 33, that collided with a Russian satellite, Cosmos 2251. Now, these two satellites were on different orbital planes, so they collided at a very rapid velocity, about 22,000 miles per hour, relatively speaking. And as you can imagine, this was a violent collision that created a lot of space debris. At the time, they estimated over 2,000 large pieces of space debris created by this collision. You can see even less than an hour later, all this debris was already circling the Earth. If you've seen the movie Gravity, you know what the effects of this could be like. Definitely not good. But there were 2,000 tracked pieces of space debris, but the Arecibo Observatory, which we mentioned, unfortunately, it has been decommissioned recently. But there was a study conducted years ago that estimated approximately 1 million objects larger than 2 millimeters were created by this collision. And those objects traveling at faster than a speeding bullet would wreak havoc on anything in space. So there is a lot of danger, there's a lot of potential danger if a collision were to happen. But again, luckily, all of these satellites are tracked. This potential collision, I'm not exactly sure why it happened or why we didn't know it was going to happen, but I believe there was an adjustment to one of the satellite's orbits that wasn't communicated to another system, and that or another to another country basically, and that caused the collision. But the United States Strategic Command's Combined Space Operations Center tracks more than 8,500 objects larger than 10 centimeters in low Earth orbit. There is also, NASA has the Orbital Debris Program Office, where they study orbital debris as well. You can see a picture of one of those microscopic orbital debris causing a crack in the windshield of the International Space Station. That's not great. We don't want that. So we are tracking these objects, and there are some ideas for missions to send satellites to space to kind of scoop up some of this orbital debris. That's one idea we may end up having to do sometime in the future. But in the meantime, we are tracking most of these objects, and barring other international communication errors, hopefully these types of collisions will not be happening that much in the future. But again, low Earth orbit is fairly common. There is the space station again. We have a lot of other satellites here. I'll let you explore this graphic on your own. We can post a link to it. And then, of course, getting any closer, and then we have the Earth there. But that's low Earth orbit, and that's the breakdown of pretty much all of the Earth orbiting satellites. Now, since the Apollo program, there have been no human space flights beyond low Earth orbit. The only things we've sent to space are uncrewed spacecraft going to that zone. Hopefully that will be changing. NASA currently has a program called the Artemis program that they're planning on bringing astronauts back to the moon in just a few short years. So hopefully that program continues. Yeah, so that is kind of where we are with satellites. Checking into the comments again, we are wrapping up our stream, so if you have any last-second questions or comments, be sure to throw those in. Eric asks, when a satellite is viewed on a clear night, what orbit would it be in, mid-Earth or low-Earth orbit? That's a very good question, Eric. Now, most of the satellites you're going to be seeing with the naked eye are going to be low-Earth orbit satellites because they're going to be able to reflect enough light that they would shine brightly. Like the International Space Station, it's pretty common to see in the night sky. It orbits so rapidly every 90 minutes that you can see it pretty frequently. in fact, if you're ever curious about seeing the International Space Station, NASA has a website called Spot the Station that'll actually help you find the International Space Station. You can look up sighting opportunities in your hometown. So we can go to Kansas City, and we can look at just smack dab in the middle of downtown near my apartment, and we can see the next time you'll be able to see it. So it looks like what day is it? Yep. So it looks like tomorrow at around 6 p.m. you might be able to check it out. It'll be very low on the horizon, but you'll be able to see it in Kansas City. So check that out if you'd like. I believe you can also look at a live tracking map to see where it is above the Earth. And it's not loading. Oh, there it is. Cool. Yep, so there is the International Space Station traveling around. Looks like it's above Canada right now. There are a lot of other websites you can use, Eric, and anybody else, to track satellites. But that's a good question. I believe most of them are going to be low Earth orbit satellites, because the high Earth orbit satellites or medium Earth orbit satellites would not reflect enough light. Irene is watching. Thanks for watching, Irene. We can hear Phoebe in the background. Great job, Patrick. Maxine says hi. Well, thanks so much for watching, guys. Appreciate you tuning in. And Phoebe says hi. Phoebe threw a bit of a fit earlier in the stream. Maybe to wrap up, we'll bring her back out, see if she feels better. And then looks like Granny wants to know if we can read data from satellites from other countries, and do countries ever share access to their satellites? That's a great question, Granny. Thanks for asking. And the answer is yes. So we can communicate with other satellites. For example, Sputnik was the very first satellite, and people around the world could detect its radio signal. Now, a lot of international space agencies do have their satellites trackable via the public, so there are a lot of websites you can go to look up the locations of satellites. And we communicate with satellites all the time, whether it's using GPS navigation or getting television from satellites as well. So we do access satellites from other countries. Now, some of the more sensitive types of satellites, relating to, say, military use, of course, we keep those a bit more under wraps. And there are probably a lot of satellites we don't even know about. And then there's surface imaging satellites. In fact, kind of a funny thing I just thought about is that there are certain countries that actually alter satellite data. If you ever look up, I'll just say that at the risk of being we're going to keep this very apolitical, of course, but if you've ever looked up any satellite imagery of China, for example, and you compared that with street maps, so if you go on your Google Maps or whatever and turn the satellite imagery on and compare that with the actual street directions, the roads actually don't line up with the satellite imagery, and that is intentional. So there are certain countries, and the United States might do this too, who actually alter their satellite data just slightly so that it's just slightly off enough that it is not exactly trackable. So that's a great question, Granny. Thanks for asking that. Chris says, thanks so much for doing these episodes, Patrick. We will be going to the Laser Michael Jackson show. Ooh, I'm so glad you brought that up, Chris. And thanks again for watching. Of course, Cindy says thanks as well. And Chris brought up a great point, because I will wrap up this stream by reminding you that the planetarium is open to the public right now. In fact, we have a really fun schedule planned right now. Let's visit the planetarium's website over here. And you can find our calendar here. Oh, look, there's a free planetarium live stream tonight. But on Thursdays and Fridays at 4 p.m., we're doing a matinee laser show right now. And every week, it's a different artist. So this Thursday and Friday is Laser Michael Jackson. So you definitely don't want to miss the King of Pop this later this week. So tickets are limited, and last week we had Dark Side of the Moon, Laser Pink Floyd, and that show on Friday sold out. So if you want to see the laser show and can stop by for our matinee showing, then be sure to buy your tickets in advance, because those do sell out quick. And we've got a bunch of other cool shows coming up. Laser Prince is the following week, and then we've got Laser Beyonce, Laser Queen, Laser Beatles, Lasers of Oz, a laser version of the classic movie, and then Laser Stranger Things which contains all sorts of amazing songs and imagery from the hit show. So be sure to buy your tickets in advance. Of course, buying tickets to the planetarium is a great way to support the planetarium and to support myself and all the programs that we do at Union Station. So thank you so much for supporting us, those of you who have come out to see us. But if you're still more comfortable watching at home, or you want to do both, of course, then that is also a wonderful way to support us. So thanks for continuing to watch, everybody. Be sure to tune in next week for our next live stream, because we will be covering next week is going to be a fun topic, because it is Groundhog Day, or it will be almost Groundhog Day, I guess. Monday is the 1st of February, and Groundhog Day will be the day after. But so I thought we could do something kind of fun, and we're going to do a live stream all about, we're going to kind of do a combined live stream. I'm going to talk about time travel, so a la Groundhog Day, but also we're going to talk about retrofuturism. So retrofuturism is one of my favorite genres. Basically, classic pieces of art, classic books, classic movies that imagine a future before we knew how the future was really going to turn out. So think, Jetsons flying cars, or think, Isaac Asimov's vision of the future. A future that doesn't really exist anymore, or can't, because we know different things about space. But it's just really fun to think about how people imagined space back then. So that's what our live stream is going to be about next Monday. So be sure to tune in. Mark a calendar, 6 p.m., same place, same time. If you're watching on Union Station's page, be sure to like and subscribe to the Arvin Gottlieb Planetarium's Facebook page. Also, if you have a YouTube account or a Google account, please go to youtube.com, search for Arvin Gottlieb Planetarium, and subscribe to us there. If we reach 100 subscribers, then we can make an official YouTube channel, which will be very exciting. So if you can do that, that would be so amazing. And as a reminder, we post all of our past live streams on our YouTube channel, so you can find all of those there as well if you missed any of our past streams. For now, though, I have been your Planetarium Specialist, Patrick Hess. Thanks so much for tuning in for another week. I'm looking forward to seeing you next week, and have a wonderful rest of your week, everybody. Go Chiefs! Phoebe says go Chiefs, too.